So this video is about vectors, and vectors they measure two things. They measure length or magnitude and direction. As opposed to things like temperature or distance that only measure one thing, vectors measure these two things. So here's some examples of vectors, and all vectors have this initial point where it starts and a terminal point where it ends. And they also have an arrow that tells you the direction the vector is going, and the arrow goes in the direction of the terminal point. So when we write vectors, let's say we have this vector v that is 2, 2, and vectors have these angled brackets that denote the fact that it's a vector, and they also have these arrows over the top of them. This is called component form, and what this tells us is that the vector starts at point 0, 0, that's the initial point, and the terminal point is at 2, 2. And that's our vector. Not all vectors are going to be in this component form where they start at 0, 0. Sometimes they'll start somewhere else, like at 1, 1. So we have this vector here that goes from 1, 1 to 2, 4. And we want to put it in component form. If we just said that this vector was 2, 4, then what we'd be saying is that it starts at 0, 0 and ends at 2, 4. And obviously these vectors are not the same. So we have to do something to our vector to make it so that it starts at 0, 0 so we can put it in component form. So to get our y values, our first y value to be 0, we need to shift our vector down. So we go from 1, 1 to 1, 0, and from 2, 4 to 2, 3. We're just subtracting 1 from both of our y values. And now our terminal point is at 2, 3. And to get the x value to be 0, 0, we shift it back 1. So we're now at 0, 0, and our x value for our terminal point is now 1, and the y value stays the same. So now our vector starts at 0, 0 and ends at 1, 3. And this we can put into component form since it starts at 0, 0. So this vector v, is 1, 3. And these two vectors are the same, but this one starts at 0, 0, and so we can put it into component form. We have a formula that will help us so that we don't have to draw this graph every time. If we have a point P, that is P1, P2, and a point Q, Q1, Q2, and if P is our initial point and Q is our terminal point, then we can use this formula to find the component form of the vector. So the vector is Q1 minus P1, Q2 minus P2. And this is the component form of the vector. So as we said before, we can find the length or the magnitude of a vector. So we'll just use the vector that we were using a minute ago. It has an initial point at 1, 1 and a terminal point at 2, 4. The formula for finding the magnitude of a vector is similar to the formula for finding the component form. It's Q1 minus P1, but we square it. And we add Q2 minus P2, and that's also squared. And then we square root the whole thing. And the notation for magnitude is these double bars. If you see those double bars, then you're being asked to find the magnitude. So the magnitude of this vector, PQ, would be the square root of Q1, which is 2, minus P1, which is 1, squared, plus Q2, which is 4, minus P2, which is 1, squared. And that is equal to 1 squared plus 3 squared, which is the square root of 1 plus 9, which is the square root of 10. So the magnitude of the vector that starts at 1, 1 and ends at 2, 4 is the square root of 10. Now that we know the component form and the magnitude, we can show that two vectors are equivalent. I'll turn this like this. If we have this vector, we'll call it vector v, that starts at 0, 0 and ends at 3, 2. And we also have a vector u that starts at 1, 2 and ends at 4, 4. And we want to know if these vectors are the same. This is our vector u. And in order for them to be the same, or to be equivalent, they have to have the same length and the same direction. And by length, we mean magnitude. So do they have the same magnitude and the same direction? We already know how to find the magnitude, so we can find the magnitude of v, which is, using our formula, the square root of 3, sorry, this is 0, 0, is our initial point, so 3 minus 0 squared plus 2 minus 0 squared, which is the square root of 3 squared plus 2 squared, which is the square root of 9 plus 4, which is the square root of 13. So the magnitude of vector v is the square root of 13. Now we can find the magnitude of u and see if these magnitudes are the same. So using our formula, the magnitude of u is the square root of 4 minus 1 squared plus 4 minus 2 squared, which is the square root of 3 squared plus 2 squared. And as we saw before, that's 9 plus 4, which is the square root of 13. So these vectors have the same magnitude. Now we need to see if they also have the same direction. And we can do that two different ways. We can put these vectors into component form, or we can find the slope, and we'll do both ways. So to put them into component form, well, we know that v is already in component form since it starts at 0, 0. So the component form of vector v is 3, 2. The component form of vector u is 4 minus 1, 4 minus 2, like the formula that we saw before, which is also 3, 2. So these vectors have the same component form, so that means they have the same direction. Using the slope to find this, the slope of our vector v, if you remember, slope is the change in y over the change in x, so 2 minus 0 over 3 minus 0, which is 2 over 3. And the slope of u is 4 minus 2 over 4 minus 1, which is also 2/3. So again, they have the same slope, so they have the same direction. So there's two ways that we can determine the direction if two vectors have the same direction. And because these two vectors have the same magnitude and the same direction, we know that they're equivalent.